theorem.
Okay, students, let's learn divergence and the Stokes theorem. They play a significant role in the electromagnetic because in electromagnetic we used to convert this differential form into the integral form or integral to differential. Okay, and this volume to surface integral and surface to line integral. So for that we require two types of theorem, that is divergence and the Stokes theorem. So in this video I will explain you and tell you how to remember these Stokes theorem, because you study a theorem and after some time you forget it. But here I'll tell you the trick to remember these theorems. Okay, so first of all, let us start with this divergence theorem. So this theorem is basically used or we can say that this theorem defines the volume integral of the divergence of a vector field. Okay, so volume integral of divergence of a vector field means, let us say this is the divergence of any field A. Okay, del dot A is a divergence, and the volume integral of this will be equal to volume integral, take the volume integral, that will be the volume integral. So the volume integral of the divergence of a vector field equals the total outward flux of the vector through the surface that bound the volume, means that would be equal to the surface integral of that field. Okay, so this would be a vector. So the divergence of any field, volume integral of the divergence of any field is equal to the outward flux, that A dot ds, the surface integral is also equivalent to the outward flux through the surface that bound the volume. Okay, so this surface will bound that volume. Okay, this is the meaning of this. So this theorem is basically, this theorem is divergence theorem. Okay, and another theorem is, that is basically used here in electromagnetic, is Stokes theorem. So it says that the surface integral of curl of a vector field, again let us assume that this A is a field, so the curl is given like that. Okay, and that this surface integral dot ds. Okay, so this okay, let's okay, this is all right. So here this s is here is vector and this volume is a scalar. Okay, so don't confuse in this. We don't have a dot product here, simple product here. So okay, don't write anything here. Okay, it is like that, del dot a divergence and simple dv, no product, because it will produce a scalar quantity. Del dot a will give you the scalar quantity. Okay, so simple multiplication with the volume. Okay, and here this del cross a will give you the a vector, so you have to take the dot product with the surface. So surface here is a vector, so we can say that the surface integral of curl of a vector field, surface integral, so this is the surface integral, this is the surface integral. Okay, that's all. This is the surface integral of curl of a vector field is equal to closed line integral. Okay, closed line integral of that vector field. Which one? This A, close line integral. Okay, vector along the counter along the contour bounding the surface. Okay, this line integral along the contour bounding the surface S. Okay, so that would be your Stokes theorem. So basically what divergence theorem is, it is used to convert this volume integral into the surface integral. Okay, basically if we just look in this, and this Stokes theorem is used to convert the surface integral into the line integral. Okay, so this will goes like this. So trick is volume, surface, line. This is the volume integral, this is surface integral, this is the line integral. Okay, so always we can convert this volume to surface, surface to line. Okay, so let us start with the divergence. Divergence means dot product. So dot product with any field. Okay, so take the volume, and volume can be converted to the surface integral. Okay, so this divergence theorem convert this divergence of any field uh, with the volume integral into a surface integral. Okay, again, so the Stokes theorem convert this surface integral to the line integral. Okay, so we have already taken this divergence, so here we will have a curl. So curl of surface integral of curl of any field is converted into the line integral. So this is the short trick to remember the divergence and the Stokes theorem. So they play a significant role in the electromagnetic, because many a time you need to convert this volume integral into surface and surface to the line, and you have to write this differential forms and integral forms of many these quantities. So we will use this divergence and Stokes theorem frequently. So that's all for today.